All right. Welcome to Nutley Cisco Academy. Today, our presentation is on communication in a connected world. Everything is online. Constant connection. Today, devices such as smartphones, laptops, and tablets are expected to be constantly online. The internet has been integrated into our daily lives, used for social media, shopping, learning, and work. Internet as a network. While people think of the internet as a place, it's actually a global network of interconnected systems. The internet is more than just a collection of devices, it's an essential framework for global communication. Oh, what the hell? Who owns the internet? No single ownership. The internet is a public, decentralized network. No one person, company, or government owns it. Instead, it's actually made of various networks, all the following common standards that work together to ensure information exchange. No, no, no. Go back. All right. How it works through different types of physical connections, fiber optic cables, wireless transmissions, and satellite links. People around the world can send and receive information.
How network connects us. Smart devices like smartphones, tablets, and computers use the internet to stay connected, share information, and access services. Example of global connections. Handheld devices receive news and messages. Video conferencing connects people in the different parts of the world instantly. Phones connect globally, share voices, text, images, and more. Online gaming allows people from around the world to connect and interact in real time. Local networks, small networks, SOHO networks, home and small office networks allowed devices to share resources like printers and documents. Business networks. Larger networks allow businesses to streamline processes like communication, marketing, customer service, and information sharing. These networks help reduce communication costs and increase efficiency through the methods like instant messaging. How to do that one.
Mobile devices, connecting everywhere. Mobile devices such as smartphones, tablets, and smartwatches enable access to the internet wherever you go. Smartphones, they integrate multiple functions such as voice calling, photography, navigation, entertainment, and putting into one portable device. Connected home devices, smart home devices, home systems like security cameras, thermostats, and lighting can now be controlled remotely through the internet. Example of connected devices, smart TVs allow streaming and internet browsing. Smart appliances can be controlled from anywhere to manage energy use, set timers, and get maintenance updates.
Other connected devices. Smart cars. Many modern vehicles now connect to the internet, offering features like GPS navigation, remote diagnostic, safety alert, and vehicle tracking. RFID tags. RFID tags, or known as radio frequency identification tags, are used for tracking products, people, and animals, providing valuable data for inventory management, security, and logistics. Medical devices. Connected medical devices can transmit health data remotely to doctors, providing real-time monitoring of vital signs like heart rate, glucose level, and more. The bit binary system. Data is represented by binary digits or bits, which can only have two states, 0 or 1. These bits form the smallest unit of information and are fundamental to data storage and transmission in all digital devices. Examples of binary representation. Light switch, it goes on equals 1 and off equals 0. magnetization. Direction of magnetism can represent bits. Every interaction with digital system is converted to binary for processing.
ASCII and byte representation. ASCII, American Standard Code for Information Interchange, represents text characters with a sequence of 8 bytes. 1 byte. A equals 0, 100,000, 1. 9 equals 0, 0, 111, 0, 0, 1. Hashtag equals 0, 0, 1000, 11. A byte consists of 8 bits representing characters, numbers, and other symbols in computers. Every character you type, every image you see, and every sound you hear is stored and processed as a series of bits. 1.2. Common methods of data transmission. Data transmissions. Once data is transformed into bits, it needs to be transmitted across the network. Types of signal. Electric signals, represented by electrical pulses over copper wire. Optical signals, represented by light pulses through fiber optic wire cables. Wireless signals use a radio, infrared, or microwave waves to transmit data over airwaves.
Transmission media. Transmission media types. Copper wire, commonly used for electrical signals in the Ethernet networks. Fiber optic cables, used for transmitting data over long distance using light signals. And wireless signals, uses radio waves, infrared, and microwaves for short range to long range data transmission. Ideal for Wi-Fi, mobile data, and satellite links. Bandwidth. Bandwidth is critical concept in networking that determines how quickly data can move from one point to another. Definition. Bandwidth refers to the capacity of the network's media to carry data. It's typically measured in bits per second and shows the theoretical maximum data transfer rate. Common units of measurement: kilobytes per second, thousands of bits per second, megabits per second, millions of bits per second, gigabytes per second, billions of bits per second. Factors influencing bandwidth: the type of physical media, current network technologies, and physical laws.
Throughput. Definition of throughput. Throughput measures the actual amount of data successfully transmitted across a medium within a specific period. Unlike bandwidth, throughput accounts for real-world conditions and limitations. Factors affecting throughput. Amount of data. Large volumes of data can congest the network. Types of data. Different type of data, video, text, or control message affect the transfer rate. Latency. Delays caused by the number of devices the data must pass through or by physical distance. Key concept: latency. Latency is the time delay for data to travel between 2 points in the network. High latency reduces throughput even if bandwidth is high. Throughput versus slowest link. Throughput cannot exceed the speed of the slowest link in the network path. Regardless of the other segment, bandwidth, this concept is critical in internet networking, where multiple segments with different speed are common. Online speed tests. These tools measure throughput by simulating data transfer between your device and a remote server.
All right, these are the questions. What are the types of networks? What are the methods of data transmission? What is the difference between bandwidth and throughput? How do communications in a connected world impact? And here are the answers. All right. If you like our presentation, click like and subscribe.